Hey everybody, welcome back. Little change of venue today. I'm sure you can tell by the background and the sound, which sounds very echoey, I'm sure. I've squeezed into a new spot back here in the shop. We've redone a bunch of area in the shop and we've enclosed more workspace, and this is kind of a storage warehouse area. And we've brought in some of our coils and we've got those lined up, and we've got capacitors and boxes and drivers and all kinds of things that we'll keep in some of these areas. And then there's an adjacent big work area that we've just finished up. We'll be building some more work tables and things for all of our guys to work and fill orders and things like that. So we've added this new space, and right now it's a little bit empty, but I wanted to take advantage of it real quick while there's no one in the other area working and it's quiet in here. And you guys have been complaining that shooting videos in the sound room in there in the listening room is kind of dark. So wanted to try this out and see if this is a little bit better. And in the future, we still got a big new listening room that we're building, and I think over in the end of it, I may set up a studio in there because it's going to be an acoustically treated room, and we'll do some videos and stuff in there. So for now, we're going to see how this works. Today, we have another Klipsch upgrade video. Of course, we've done by far more upgrades to Klipsch speakers than any other manufacturer, because they're very popular and they need a lot of help, and this is no exception. This is the Klipsch Cornwall 3. As you can see, I've got it up on the lift table. It is a big speaker, and I've got it up here where you can see it, but I'm going to let this thing down a little bit to where you can see a little more of the whole thing. And I'm going to pull the grill off, and the grill is held on magnetically, and I like that, and it's heavy. It's a big wood panel that they've stretched fabric on, and they got the magnets in the ends and stuff. So let me get this gently placed back here so it won't turn over. As you can see, big woofer, big horn, little horn. That's what we got going on here. It's a beast of a speaker. It is big, and it's designed to just sit on the floor. It's ported at the bottom, and it is a buzz box. And when I say buzz box, I mean it is a buzz box. There is not much to the construction of this box. Typically, if we were building something this large, we would have bracing here and here and here and here. We would be bracing this thing all up and down it, going in every direction to solidify these huge panels that are on this thing, and knocking on it feels like knocking on a hollow door or something. There are 2 braces in the whole speaker, and I don't really even want to consider them as real braces. It's a structural support, but you're not going to believe this, but there is one here and one here, and it runs from the front to the back. And it's a 2x4. I kid you not, it is just a big chunk of 2x4 glued in from here to the back on both sides. Yeah. Just it's like they threw this thing together with scrap lumber. I kid you not. We took some photos of it. I'll have my editor drop some of those in over here to where you can see some of the photos on the inside. And they just stapled a little bit of foam across part of the back wall, and it was very vaguely done. And so, yes, this box is going to draw a lot of attention to itself. It's going to make a lot of noise. It's going to buzz a lot. And we knew it was going to be bad. I didn't bother trying to get the accelerometer out and sticking it on it to show you just how bad it is at every panel. Just take my word for it, it's bad at every panel. And this is very typical of what we see with their production model stuff. Just lightly constructed, cheaply made. Crossovers the same way. But these are very popular speakers because they're very high sensitivity. They've got really good dynamics, and they are a party speaker. They will play loud. So a lot of people really like them. But it's not an audiophile speaker, and we're going to get into that a little bit deeper in a few minutes. But let's finish looking at what is in these things. There is a circuit that was on little risers like this, and little little risers that hold it up, and it screws onto the back of the binding post cup. All the coils are iron core inductors, the cheapest, lightest gauge, stuff you can get your hands on. Sandcast resistors, and it didn't even use any kind of polycaps. They're like a polyester film cap or something like that. So the cheapest parts you can get, all stuck on the back of the binding post cup, and the binding post cup has steel terminals on the back and steel nuts right there in the middle of the signal path for the whole signal to run through and smear everything. So it was a mess, but how did it measure? Well, not that bad, actually. We've noticed some of these bigger models, the Cornwall, some of the Heritage series, they don't measure as badly as some of the other models. In fact, let's throw a frequency response on this one up and take a look at it. We did this first at a 1 watt 1 meter at the tweeter level just to get a reference output level, and then we moved much further away to the kind of the limit of where we could gate a time window and got a good measurement on this thing. So sensitivity on this thing, and I know it doesn't show it on these measurements here, but I think the sensitivity was right at 100 dB. And on these measurements, well, let's look at the one measurement where we're on axis and then we put the grill on and we show the difference between with and without the grill. That's showing the actual output level. I think Hobbs took the measurements when they originally came in, moved it out further away so we could capture a little bit more how the drivers are blending. So the microphone was moved out to almost 60 inches. And I don't think he adjusted the output level back up to match where it was at 1 meter. So the sensitivity level is down, but it was at on an average of 100 dB sensitivity. So let's look again. Let's look at the frequency response, and we can see from distance, it's not that bad. It is choppy, but it stays within an average of 2.5 to 3 dB from end to end. So that's within a good industry standard. It's just choppy. And then looking at the spectral decay, you can see that there is some stored energy going on in this thing. And so it's going to be one of those deals where it's not going to be a fast, clean, delicate sound. It's going to be just an in-your-face loudspeaker. And all those traces you see in the spectral decay coming out there, it's holding that note longer than it's supposed to. And some of it is some of the breakup modes on the woofer. Some of it is ringing within the horn. The cabinet resonances are so bad that it may even be showing up some in the spectral decay as well. It's pretty extensive. Let's look at the impedance curve. You can see that there's a lot of choppiness all along the impedance curves. And when you see an impedance curve and you see little wiggles all across it, that's indicative of a resonance that's within the driver. So that's there, and there's not much fixing that. It's just little resonances there. And then as it goes up higher in frequency around the mid-horn and a little above the mid-horn, you can see the impedance is a little too high up there, and then it drops down again at the tweeter end a little bit. So a little bit of an imbalance in the impedance load. Let's look at the horizontal and vertical off-axis response. This is where it's really not that bad. Horizontal off-axis, let's take a look at that. That's moving 0 to 40 degrees off axis, and it's choppy. It's choppy to begin with, but it drops off pretty evenly. Vertical off axis is much better than you would expect from a speaker of this type. Going up, moving up a little bit each time. I think we went a little over 4 inches per movement because we're so far away. It may have been 5-inch measurement or 5 inches per measurement going up. We can see a little bit of a dipped area there between the woofer and the horn as you go up, but overall it keeps a pretty consistent response in the vertical range. Going down, so we're moving down from the tweeter level, going down, it also maintains a pretty smooth frequency response. The drivers aren't getting way out of phase. A lot of it is because there's 16 parts on this crossover, and there's even parts on the back side of the board. So they're pretty steep filters, so one driver's not reaching far into the next one to where when you move up or down that some of that's out of phase and causing a cancellation. It's more of a steep drop, so it's not getting too far one way or another. So we're seeing little wiggles, in the vertical off axis where the phase relationship is changing a little bit there right at the crossover point, and the driver's response is changing as you're going up and down, but we're not seeing a huge cancellation going on. So all of that's a good sign. So they did some things okay, but the moral of the story is this is a really cheaply made speaker. All right, let's take a look at what we were able to do with this thing. So, and let's start with the measurements and look at that. And we can compare to the old, and we can see how I balance things out a little bit more. Let's look at the crossover response and the range that the drivers are operating within. The woofer is one of those situations where we really couldn't pull it back any further because the mid horn wouldn't go down any lower. And if we let it up, if we let the crossover point come up any higher, the woofer got into some breakup regions and stuff, and it got really bad. So we were kind of stuck with crossing it as low as the mid horn would play. And then on top, the tweeter horn would play down a lot lower, but the response got pretty rough. And so the sensitivity also dropped down. So with this third order filter that we have on it, we were able to keep the sensitivity up. So we're averaging about 100.5 dB to 101 dB all the way across. So it's gonna be able to get out there and play. Looking at individual responses, let's look at the on-axis frequency response now compared to the original on-axis frequency response. And we're measuring these at distance, so we're not just 1 meter away on the tweeter. Notice that it's considerably smoother across the board, a lot smoother. And before we move on, let's look at the spectral decay. The spectral decay is a little bit cleaner, and we added a little bit of stuffing to the box. That's also going to help. That was some of the original problems. There was not much stuffing in there, so there was a lot of reflections in the box that are coming back. That was an issue. So what we're going to recommend with this is going to get even better than what you see in the spectral decay here. Looking at the horizontal and vertical off-axis measurements, we can see something very similar to what it was originally. The slopes that I used were very similar to what they did. Oddly enough, I only used 11 parts instead of 16 parts, and I was able to get a much smoother response. So just a little better engineering as far as the design of the crossover to smooth out that response and to keep as many parts as possible out of the signal path. We hate putting lots and lots of parts on everything because you're not improving the signal transfer by adding parts. You know, you add parts to add control and to try and maintain accuracy. In this case, we're able to do that with less parts, but much, much higher quality parts. So horizontal off-axis looks very similar to what it did before. It's smoother to begin with, so as it drops off, it's a little smoother. Vertical off-axis going up, very similar to what it was before. It's maintaining a little bit better response through part of the range there, but overall it's very similar to the way it was. Going down, also very similar to the way it was. We see going down pretty low, like dropping down to the woofer axis. We can see a little bit of a dipped area there around 1200 hertz or so, but overall, vertical and horizontal off-axis on this thing looks pretty good. The impedance curve. Let's do a before and after on the impedance curve, and you can see that some of those little resonances within the woofer's response is still there. It's going to help once you load this thing with no resin insulation and absorb some of that back wave that's going on in there. That may knock some of that out. It's going to improve the spectral decay, and it's going to sound a lot cleaner. Right now you're just hearing some of those reflections in that hollow box, and we threw, like I said, we threw a little bit of fiberglass in there, and that did help quite a bit. So that also indicates that once you take it on out there and properly damp the inside of it, it's going to make big improvements. One other thing I want to take a look at, and this deserves a little bit of explanation, is, and it comes back to the reason I'm not a big fan of horn speakers. Because people have asked me, Danny, why don't you like horn speakers? Well, there's several reasons. One is I'm an imaging freak. Like, I really like deep three-dimensional layered sound stages. And it's really hard to get there with a speaker like this for two reasons. One, the baffle is huge. Anytime you get a great big baffle like this, and I mean, it's almost 30 inches across, it's always going to sound like it's playing from that baffle forward. There's just no way around it. It's just going to have that sound. And then when you have offsets of the voice coil, like in this case the woofer, its voice coil is say here on the cabinet, and then the mid horn, its voice coil is like 3 inches from the back wall. So there's a difference there of about this much offset. And then the tweeter, well, its voice coil offset is just a little bit set back. So there's a big difference in how far the voice coils are set back in time. So let's look at an impulse response and see kind of what that's doing. Normally with some of our speakers, we'll see an impulse response, and you'll see the response, and then it'll settle, and then it's fast settling, and then it's just flat. Here you notice there's that initial impulse response where the tweeter's reaching the microphone, and the woofer right there with it, or right along behind it there just a little bit. And then it's flat, and then you see a whole new wiggle there that's the mid horn. It's like it's delayed in time. And when you delay drivers in time versus each other, even though we go in with the crossover and we shift phase and stuff in a way to where they're in phase, it's like the wavelengths from the measurement are arriving in time with each other, sort of. It's in time in the fact that it creates a smooth response. So you can say, okay, everything's in phase. But in this case, the mid is so much further behind it. Think of it as like the tweeter plays its wavelength and the mid plays its. So it's got tweeter, mid, and they're coming like this. And then when they sum together, what we're trying to do is make sure that these are in time with each other and they're not doing this with each other and canceling each other out. So in this case, what we're timing to is the tweeter several wavelengths back, or at least a full wavelength back, is what we're catching, and we're trying to time the mid horn to it. So it's in phase, but it's not. It's in phase in that they're not canceling each other, but they're not in time because the mid is behind it in time. So think of it as the mid wave did this, and then it caught up to the tweeter, and they were in time with each other. Think of it as drum hits. Like one guy's hitting a drum, and then the next guy's hitting the drum, and they're out of time. So it's kind of a boom, boom, boom instead of a boom, boom. They're out of time. So if one of them is delayed in time versus the other, you can actually shift it to the point where they're in time, but they're a beat behind. So think of it that way. It's this first beat is in time with the other beat on the other drum, but it's the first beat is the second beat, and the next drum is the first beat, and you've timed the beats, but they're not the same hits. So what happens when you play back the music through the speakers, and there's a little bit of a time delay between stuff. It's not coherent. Things aren't where they're supposed to be in the soundstage. It pushes things forward or further back, and it shifts things around in an unnatural way. Whereas we're used to hearing things with all of our speakers for that matter, where we're really trying to create that three-dimensional soundstage, and the way we're doing that is making sure everything arrives in proper time so that your left ear and your right ear hear that perfect blend that was mixed, and then where those things are in the soundstage become real apparent. Like if a voice is further back than another voice and things like that, and the acoustic guitar's playing, and you hear that high detail of the strings, and you hear the body of the guitar, but you want to hear it as one instrument. You don't want the highs to be here and the body to be here. And that's what happens when you start causing big phase shifts like that. You're causing a time delay of one driver's completely behind the next driver. And the big baffle problem again. Those things work against all the things that we're trying to create. So I'm not a big fan of the horn speakers. That doesn't mean you can't listen to horn speakers and enjoy them. They can be a lot of fun. You can crank up a lot of old 80s rock and roll on these things and be in heaven. Like you may feel like this is great. I've just got a speaker sitting on the floor right here and one right there, and it's against the wall, and I really don't care about imaging and soundstage layering. I just want it to be loud. I just want it to be a wall of sound, and that's what these things will do. So there's a limit to what the capabilities are on these things, and they're not for everybody. It depends on what your tastes are and what you like and what you're listening for. Now, I also wanted to come back to the crossover quality on this thing. On the new crossover, as you can see, there's 3 coils here. They're all air cores. And the caps are poly caps, and in the tweeter circuit, we're going to offer a sonic cap option. So you can upgrade those to sonic caps. The sonic caps are a little more expensive, but they're also much faster and cleaner than a lot of other types of capacitors. So you're going to hear detail and clarity and more space between notes and things like that. We're also going to throw in a set of tube connectors, and that's going to be a huge improvement in the signal transfer over this. So even though the frequency response may have looked okay before, don't think, well, I can just EQ that a little bit and I can reach the same thing that Danny did with his crossover. No, you can't. It's going to sound completely different. Even if I replicated this crossover with these parts, with the higher quality parts, it would not sound the same. There's a big difference in, like the coils, for instance, cause smearing. Air cores discharge a lot faster. They don't hold the charge within the core. It's cleaner, it's faster, it's more open sounding. Capacitors that are not only polypropylene, but really high quality polypropylene, they discharge at a much higher rate, much faster. So you hear a whole lot more resolution and detail than you would with the original crossover. So it's going to be a big difference. Even the resistors cause issues, whereas we're using these pure copper type resistors that are much cleaner sounding. So new wiring, the original wiring, all PVC wiring, and if you've got one of these and it's 8-10 years old, that wiring may have already started oxidizing. It's PVC jacketed wire. A lot of that stuff will oxidize right through the jacketing, and especially around the ends where they cut the ends and they solder it on here and they don't use any heat shrink or anything on it, and that oxidation just starts coming right up the wire. So even all those little things matter, and in this case, they're going to matter a lot. We're going to transform this speaker into something that sounds balance-wise very much like it did, but a whole lot better presentation, a whole lot more. You're going to hear a lot deeper into the music. And now, the other thing is, we're going to recommend you guys go in and add bracing to this thing. And what I mean by add bracing, let's take some 3/4 inch MDF and just cut 3/4 inch sheets or sticks out of it. So you got 3/4 inch by 3/4 inch squares. You just got a almost like a square dowel rod. And then on the ends, you want to cut those at a 45-degree angle. And here's what you're going to do on this thing. You're going to glue one from the front to the side, and from the front, maybe up here next to this 2x4 over to the side. And you can line this front baffle with quite a few. And then from the back panel, you're going to go from the back panel to the side panel. Glue that stuff in and lay it on its side and just press that stuff in. Use a good wood glue and press it down on there and just leave it there till it dries. It'll suck down, that glue will draw that thing in and it'll dry. And when it is, flip it over on its top. And then once it's sitting on its top, glue some more of these diagonals in. Glue from the side to the top and from the back to the top. And just glue in a little lattice of these things. Then flip it over to its other side and glue braces in on the other side. That way you're structurally just containing this thing so that it will quit flexing, because right now, when you play bass notes on this thing, the whole cabinet is flexing. And that's just nullifying everything that the speaker's doing. It's sucking away output and it's coloring the sound. It's like, it will take the sound of a good bass guitar or electric guitar and make it sound like it's playing out of a radio. I mean, it'll really take the liveliness out of it. So we recommend that you glue that stuff in there. And then we're going to throw in sheets of no-res with this kit, and I want you to cut these no-res into pieces and just go in there and line the whole box with no-res. So now we're going to damp out any remaining resonances of the box. So the box was flexing a lot. It was resonating a lot, making a lot of noise. You're going to glue all that stuff in there, and you're going to add the no-res, and not only are you going to stiffen it so it won't flex, but any areas between the braces, you're going to damp out those resonances. And the difference in performance in that alone is going to be considerable. It's going to sound a lot cleaner, even all through the vocal region and everything. It's going to sound a lot better. And it's easy to do. And a little sheet of MDF. Doesn't cost much. You can even use some scrap, or you could use some dowel rods. You can use plywood, whatever you may even have laying around. The idea is to cut into these narrow strips, and the reason I say cut them into these little rods is because you're not taking up a lot of airspace that way. And this is a big box. You've got a little bit of airspace to play with here. And you don't want to just go in and just do huge, all the way across braces, you know, that are going to take up a lot of airspace. You're going to start eating into how far this thing plays down low. So a lot of those little small ones is not going to take up much space. And then when you line it with no-res, the no-res is going to, it's got a foam layer, so it's going to slow down the airflow in the box a little bit and make the box active if it's larger. Then go in and add your fiberglass insulation, add some right above the port, add some right all over the back wall, add it all in the back at the top and around the horns and all that stuff. And now you're going to get back the airspace that you took up with adding those braces. So it's going to be somewhat neutral when you're done. It's still going to be tuned at about the same frequency that it was. You're just going to make it sound a whole lot cleaner and a whole lot better. So that's kind of the way to go about controlling the box and working on the box and doing all that stuff. So the combination of doing all of that, it's going to turn this into a pretty fun speaker. It's still not going to have the imaging and the soundstage layering and stuff of a mini monitor. It's just not going to do that. But for you guys who are looking for high sensitivity speaker and you bought these thinking this is going to be it, and then you realize a lot of stuff doesn't sound so good on this, then this upgrade will help transform these things into sound into something at much higher quality. And you can take some of those leftover pieces of no-res, like some of the little strips on the end, pull the foam off, and glue those things all across the horn on the back side of the horn. Like glue them in between on the horn, and it'll help damp out some of the ringing of the horn. Same with the woofer. You can always do that on the woofer frame. Put a few little strips on the frame of the woofer, and it'll help damp out some of that ringing on the woofer. All those little things help. They all make a little difference, and a lot of little things aren't necessarily little things anymore. They're big things. So thanks for sticking with me through this whole, it was almost a tech talk style video. I understand that, and I know a lot of you guys like videos like that. But it went a little long. I hope you don't mind the new back room recording that we're doing. Hopefully the echo is not too bad, and hopefully you can make it through it without too much complaint. Always give somebody always complains about something. Oh, the lighting is too dark. At least it's not too dark in here. You can see everything this time. So bear with us. We're going to do videos maybe in some different areas until we get the new listening room finished up, and we'll have a nice dedicated, nicely lit, well-controlled space in there for audio and stuff. So hopefully then the quality of the videos will come up as well. So hang in there with me on that stuff. If you haven't subscribed to our channel, please do, and hit the like button so that it pumps our views up and everybody can see them on YouTube. That's it for this one, and we'll see you guys in the next video.